Okay, so these are our topic 24 notes, which is linear regression and correlation. Okay, and so it asks you to make a line that hits as many points as possible. It said some young athletes are throwing a discus, and the age and distance thrown are recorded for each athlete. I have you over here. So, do you guys think the age of the young athletes is on the x-axis or the y-axis? Yeah, so I'm going to label it age. You can even put in years. And then this would be the distance thrown, and it doesn't tell us the unit. So I'm just going to write distance thrown over here. Okay, and then it says to, after you draw your line that you want to estimate an equation for the line. Your line doesn't have to be exactly like mine. I didn't use any special procedure to find that line. So you might have a different equation from me. But to estimate the equation, I did learn this from another IB teacher. It's slightly different than how I may have done this in Algebra 1. One of the points you want to use is going to be the average of all the x's, comma, the average of all the y's. And so what I'm going to ask you guys to do is, if you are sitting on the side of the room closest to me, which would be like Asan and Kate and Sophia L over, then I want you to find the average of all the x values. And if you're on the side of the room farther from me, I want you to find the average of all the y values. So, and I want everyone to do that so that if somebody makes a typo, we can confirm which answer is right. Okay, so take a moment and find the average of all the x's and the average of all the y's, depending on what side of the room you're on. Okay, so when we average all the x numbers, we get 15, and when we average all the y numbers, we get 29, and that's really independent of the line you drew, because we're all using the same points. And then the other one should be any point on the line, so I just use this last point here, which is 20, 50. Okay, so I use those 2 points, and then I use point slope form. It doesn't tell you what form you have to write in, so you could have chosen a different form, and that would have been fine. So point slope form, remember, is y minus y1 is equal to m times x minus x1. That's the form I'm going to use. I also need to find the slope, of course, right? So the slope would be y2 minus y1 over x2 minus x1. And I get 21 over 5. Did you guys get about 4 for your slope when you guys were finding the equation of your line? Something close to 4 or 5? Because that's going to be about 4.2. And then I'm going to use this one. So it'll be y minus 29 equals, and then my slope, and then x minus 15. And that's your slope, point slope form. You could distribute it and move everything to one side so that you had like slope intercept form. You could do whatever you want. Okay, so that's, even though we used a procedure there, that's still an estimate, right? Because I drew a line that went through the point 2050. Your line might not go through 2050, and so you would get a different estimate. And you know that your calculator can do a line of best fit. I'm pretty sure you've done that already in a different class. You've done a line of best fit on a calculator or on Desmos. And they can do the line of best fit. And they will give you, the actual calculated line of best fit. But if you didn't have a calculator, this is a decent estimate. Are there any questions on the warm-up? Okay. All right, so we're going to talk about correlation. We can observe the relationship between two numerical values using a scatter diagram. So looking at the diagram kind of gives you an idea about how those two values are related. For example, looking at this graph, even without a line, I could tell you that as the age increases, what also happens? Very good. As the age increases, the distance thrown increases, and that's not always true. Okay. So that's why we make the scatter diagram. We usually put the independent variable on the horizontal axis. So the independent variable is usually the thing that you can't change. And then the dependent variable depends on that. So I can't change how old I am, but I can change how far I can throw if I work real hard at it. But they're saying here that the dependent variable will depend on your age. And it kind of looks like it when you look at this graph here. So dependent variable would go on the vertical axis. Sometimes you don't really have an independent or dependent, but usually you do. Correlation refers to the relationship or association between two numerical variables. When describing the correlation, we use the following direction, linearity, whether or not it's linear, strength, outliers if we have outliers, and causation. And you can't tell causation from a graph. Like maybe you've heard before, correlation does not imply, correlation does not imply causation, which means just because two things line up like that doesn't mean that one causes the other. Sometimes they just both happen to go up or go down. But here we can talk about if you see it going up with a positive slope, it has a positive correlation. A negative slope would be a negative correlation. And something like this, sure, you could draw a line that goes through it, but who knows? Does that go down? Does that go up? Does it go sideways? That would be a no correlation. All right, next page. All right, when the trend exists, if the points approximately form a linear line, then we would say that the trend is linear. So sometimes the trend is linear, but sometimes it's not linear. Anybody know what shape that would be there? It might be exponential, it might be logarithmic. It kind of looks like a logarithm, but it really depends on if it levels out horizontally or vertically. But that's definitely not linear. Well, it should actually have an arrow in both directions. The leveling out part, you still have an arrow even if you have a leveling out. All right, strength. To describe how closely the data follows a pattern or trend, we talk about the strength of the correlation. So the more of the points line up on a straight line, the stronger the correlation is. And that's something that you can kind of imply just looking at the graph. But you can call the correlation strong or moderate or weak. And so looking at the graph, you should be able to give a rough estimate as to whether the correlation is strong or moderate or weak. It could be a weak positive or a weak negative. All right, and then you can identify outliers on your graph. Like notice here, we have a line of best fit that is close to most of the points except for the outlier up here. Sometimes the outlier indicates that you made a mistake. So if you see an outlier, you should go back and check. First check and make sure, did you graph the right point? And then you can even go back if you collected the data and see, did you collect the data right? If you did collect the data right though, and if you did graph the point correctly, then you should keep your outlier. Okay, and causality is not always something that we can explain just by observing a graph. It just means that just because two variables are correlated doesn't mean that one causes the other. One term that we use in IB, instead of independent, we use explanatory. So instead of independent or X, we use explanatory, and then instead of instead of dependent, we use response. dependent. And that would be your y variable. So those are just vocabulary words. If you see explanatory variable and response variable, that's talking about the x and the y. All right. So you may have had a class where you determined what regression fit best by comparing r squared or r values. And so that's what we're going to talk about next. We're going to talk about the correlation coefficient. So raise your hand if you've ever created a line of best fit, either on a calculator or on Desmos, where you have a table of values and then you create a line that goes through them. Okay. If you took regular Algebra 2, you did last year when you did trash get ball, it wasn't a line of best fit, it was a curve of best fit. But if you took regular Algebra 2, you did that last year. If you took honors Algebra 2, I'm pretty sure you also did a line of best fit at some point. So you can do a line of best fit on your calculator by putting your data into your lists. And then you would do stat, calculate, and linreg. The thing is, though, that your r squared and your r don't come up automatically. That's something that has to be turned on. So you may have already turned it on, or if your calculator has not been cleared, it might be turned on from before. But here's how you turn it on. You're going to go to down here. You're going to go to mode and go down to stat and turn your diagnostics on. So let's just do that now so that we're ready. So I'm going to show that again for the recording. So you have to go to mode and then you go down to stat diagnostics and turn them on. And then that's it. And then you can do second quit to get back to a normal screen. Okay. And so there's more directions here for viewing the graph. All of this is really difficult to look at when you're not actually graphing something, so we'll probably have to come back to this when we're graphing something. But the directions here are for putting data into the lists, and then for viewing the graph, and then over here for doing the linear regression. So let's see. This one here is going to be for doing the linear regression. All right, and so we're going to come back to this because it's a lot to look at when you don't have anything to do with it. The R values can range from -1 to +1. The sign, positive or negative, indicates the direction. So if you have a positive R value, you're going to have a positive correlation or a positive slope, and a negative R value, a negative correlation and negative slope. The size of R indicates the strength. Okay, and this down here is going to be very useful to you. So let's give it like a star, because you're going to have to come back to this when you're trying to figure out if it's a strong or a very strong, a moderate, a weak, or a very weak correlation. So you can see the numbers really close to 1 are very strong. The numbers really close to 0 are very weak. Okay, let's turn the page because we're going to have a chance to use those directions in just a minute. All right, number 1. The Department of Road Safety wants to know if there is any association between the average speed in the metropolitan area and the age of drivers. They commission a device to be fitted in the cars of drivers of different ages. So these are the ages, and then this is the average speed in kilometers per hour. The results are shown on the scatter diagram, and the R value is positive 0.027. Describe the association. So going back to our chart here, 0.027 would fall where? Yeah. You see that here? 0.027 falls on this interval, which is a very weak, and is it positive or negative?
Positive.
Positive. So we're going to say a very weak positive correlation. So, if a politician was trying to use this study to say that we should raise the driving age, that you can't drive until you're 18, would you say that this study would make that conclusion?
No.
No, because it's very weak, even though it is a positive correlation, which means that as your age increases, your driving, actually it's the other way, right? As your age increases, your driving speed increases. So if we were trying to use this study, we would say, no, only let the younger people drive. But again, it's very weak, so it's not going to be useful in any way. All right, here we have some data that we can actually use. We're going to start by just drawing a scatter plot of the data, and we're going to put quality of the chemical on your x-axis, and then the number of surviving beetles on your y-axis. All right, and then we're going to label numbers. And then we're going to just do a quick scatter plot. It doesn't have to be perfect. It's hard to do perfect when you don't have an actual grid. But do your best. Okay, so then it says to determine the correlation coefficient for R. So this means we're going to have to put this data into our lists. So I want you to do stat, edit, and you're going to put the X in L1 and the Y in L2. So I did stat and then edit, and I'm going to clear my lists, clear, enter. Okay. Okay, so once you have your data in your lists, then we're going to go stat calculate linreg. So I'm going to put that on the paper first. So stat edit, and we entered the data, and then stat calculate and linreg. That's a linear regression. Stat calculate. Linreg is number 4. You want to make sure it says X list in list 1 and Y list in list 2. I don't think it matters about the frequency list, but just in case, I'm going to clear it. Now, because I turned my diagnostics on, I have the R squared and the R value. Is there anybody who does not have an R squared or R value when you do your linreg? If you don't have that, you would go back and turn on your diagnostics, and I can show you how.
Wait, do we put anything for store?
Stats, calculate for, oh no. So just make sure L1's in X list and L2 is in Y list. Okay, and we're gonna write down your correlation coefficient, which is R. So my R value to 3 sig figs would be negative 0.859. Is anybody getting something different? Okay. All right, so we're going to use that number to describe the correlation, and we're also going to make a sentence describing the trend on the graph. So because it's a negative correlation, would you say that it is strong, moderate, weak? It was negative 0.859. So I'm looking at the previous page. Where does that fall on the previous page? Moderate, yeah. I'm going to turn back. Yeah. So negative 0.859 falls in the moderate correlation. So it's a moderate negative correlation. And then the other sentence we're going to write is that as quality increases, what also happens?
The number of sprouting beetles decreases.
Right. So as quality increases, the number of surviving beetles decreases. All right, so you notice when you did that regression that you had an R and you also had an R squared. And so we're going to talk about the R squared next, okay? And after we talk about R squared, we'll take a little brain break. I'm just going to put that note here so I don't forget. Brain break. Okay. All right, so the R squared has its own name. It's called the coefficient of determination. And to help describe the correlation between the two variables, we can also calculate this. It is simply the square of the Pearson's correlation. However, notice that by squaring it, it's going to always become positive. So the coefficient of determination is always positive. It won't tell us the direction. If there is a causal relationship, then the R squared indicates the degree to which the change in the independent variable explains the change in the dependent variable. So if I had an R squared value of like 0.75, then that would tell me that 75% of the change in Y. May I turn the page? All right, the difference between R and R squared. R tells us how strong our correlation is, but R squared tells us how well our line of regression fits our data. Here we have a father-son camp, and the heights of the fathers and their sons were measured, and I had the hardest time trying to figure out how to label these axes. There really wasn't a good way to fit all these numbers in. One thing you want to do is show a break. So I'm going to start right here. I'm going to show a break here. I'm going to start right here. And the x-axis is father's height. And then the y-axis is son's height. And I'm just going to start at 165 after my break. And then I'm going to go 2 lines and then make it 175. And go 2 lines and make it 185. There really wasn't a good way to fit all these numbers in. That's for the father's height. The sons were a little bit shorter, so I'm going to start at 150. Go 2 lines to 160. And then go 2 lines to 170. And 2 lines to 180. Yeah, so I'm going to read that to you because I can see that that's not really easy for you to read. You ready? Father's height, make a break, and then 165, skip to 175, 185. For son's height, make a break, 150, skip to 160, skip to 170, skip to 180. And then take a moment to draw. We do have a unit for both the heights. They're both in centimeters. Okay, once you have that scatter plot done, then you're going to enter your data into your list to calculate r squared and then interpret its value. How much time do you need for getting that data into your lists? You guys are ready? Okay. So once you have the data in your lists, then you can calculate the linear regression. We haven't started actually using the regression yet, just the correlation. Stats, calculate, linreg, and make sure it says L1 and L2. All right, and we're using this time the r squared value, which to 3 sig figs is 0.683. Okay, and let me switch back to my camera. And then to interpret it, remember that the r squared tells us how well our line of regression fits our data. Also over here, it indicates the degree in which the change in the independent variable explains the change in the dependent variable. So we can say that 68.3% of the variation in sun sites can be explained by the father's heights. Okay. All right, we're going to take a 5-minute brain break. All right. So interpolation and extrapolation. Interpolation is when you find values, make predictions that are between your smallest and your largest values on your table. So they call these poles. So the highest and the lowest x values are called the poles. So if we predict a y value for an x value between the poles, we say we are interpolating. And if we predict a y value for an x value outside of the poles, then we say we are extrapolating. What does your intuition tell you is going to be more accurate to make predictions between the poles or outside of the poles? Between the poles, right. So interpolation is going to be more reliable than extrapolation. All right. For the next one, instead of drawing the scatter plot, which can be a little bit tedious, we're going to look at the scatter plot on our graph. And so we're going to enter the data into our list 1 and our list 2, and then we're going to look at the scatter plot together. But we're not going to graph it, because it's just getting to be a lot to graph. Okay, so turn the page, and let's put these numbers into list 1 and list 2. So we put the income into list 1 and the grocery bill into list 2. All right, in order to see the points for the graph, we need to turn them on in stat plot. Stat plot is up here above the y equals, so press second and then y equals. And we want to turn the plots on for list 1 and list 2. So we're just going to turn on this first one. So press enter and press on. And you want it to look like this screen. So after you pressed second, y equals, and then you press enter, you're going to turn this one to on. Make sure this one has scatter plot, list 1 and list 2. You want this mark right here. It's just the easiest one to see. I don't care what color you make it.
We can't change the color on our calculators.
Yeah.
Is it plot 1 off?
Plot 1 was off to start with, but we're going to turn it on. So second stat plot, it was off. Yeah. And then press enter and you want to turn it on. Okay. All right, then we're going to press graph. Now, depending on the last thing that was graphed there, like you might have some sort of graph that doesn't look like what you want. So the first thing I'm going to do is go back into y equals and clear that out. And then I need to do a zoom, and I can try zoom stat. Zoom stat is 9. And that worked pretty well for me. Okay? Raise your hand if you need help getting to this. I'm going to review the steps one more time. We did stat, edit, and we put the data in the lists. Then we did second and y equals. Second and y equals, and we get to this screen, and we're going to turn the plots on for plot 1. So press enter. Okay, and then make sure that it says scatter plot, and you have this mark, and turn it on. Okay, and then you can press graph, but if you don't see it right away, go to zoom stat, which is choice 9. And you should get this graph. Is anybody having trouble with that? Okay, so now we can see it's a positive correlation, possibly possibly strong or moderate, not going to be a weak correlation there. So you can see that there. Now it says to find the equation of the regression line. So I'm going to go back to stat and calculate, and I'm going to do my linreg. Okay, and the equation is y equals ax plus b. You substitute these values in for your a and your b. And so doing that, I should get y equals 4.18x minus 56.7. Those are my a and my b values.
If we're using 3C, 6 figs, would it be 4.19? Or do we not want to?
Did I round it incorrectly? It's possible. Let's see.
No, it's 4.178.
Yeah. So because of this 8 right here, you're going to round this one up to 8.
Okay.
Yeah. Good question. All right. State and interpret the gradient of the recession line. So it's been a while since we used the word gradient. What does that mean?
Slope.
Slope. Good. So here's my slope. When I interpret it, it helps me to make it a fraction over 1, because then I'm talking about my change in x over my change in y. So the change in x is how much my income is increasing. Okay, so I'm sorry. Yeah, that's my, no, sorry, it's change in y over change in x. I had it backwards. Change in y over change in x. So this is telling me that my grocery bill increases by $4 or 4.18 pounds. I don't know how you say that in pounds. Increases by 4.18 pounds when my income increases by not 1 pound, but one what?
1,000 pounds?
Yeah, by 1,000 pounds. All right, and that is really a very good interpretation question that they can ask you on an IB exam. Interpret what your gradient means. Estimate the weekly grocery bill for a family with an annual income of 95,000 pounds. So would we put the 95,000 for the X or for the Y?
For the what?
It's telling you that's the income,
Oh, X.
X. And since X is in thousands of pounds, I don't actually use the number 95,000. What number do I use?
95.
95. Okay, so because this is income, this is going to go for X, but we're just going to use 95 because 1,000 is part of the problem already. So I'm gonna write y equals 4.18 times 95 minus 56.7. All right, go ahead and do that and find the grocery bill, and then if you're working ahead, you can do the next one. What was that? 4.18 times 75 times 56.7. All right, so the grocery bill to 3 sig figs would be $340. If you wanted dollars and cents, it would be $340.40. I would include both answers because when I'm talking about money, often I want dollars and cents. So not dollars, but pounds, right? I get confused. 340.40 pounds, or rounded to 340 pounds. All right, we're gonna estimate the income if the grocery bill is 100 pounds. So this time the 100 goes for the what?
Y.
For the y. So back to the same equation, and you put the 100 here, and you're gonna solve it. Okay, so go ahead and solve it. All right, and this one we're finding the annual income. So I think it's fine to do 3 sig figs for this one. Okay, so add the 56.7, 156.7 equals 4.18x, divide it. And do you guys also get $37.5 thousand pounds? Thank you. X equals pounds 37.5 thousand. Okay. Comment on whether the estimates in D and E are likely to be reliable. So we have to consider our polls. What is the smallest income that was recorded?
45,000.
So that's my min. And the largest?
64.
That's my max. Okay. So which of these problems was interpolation? D or E? Interpolation is between the two poles, between the min and the max. So E gives us an x value that's between 25 and 64. In D, we used an x value that was outside of that, okay? Extrapolation, right. So we would say that D is extrapolation. Which may be less reliable. All right, and E is interpolation. And we have a strong linear correlation. So this one should be reliable.